Bismillahirrahmanirrahim. Assalamu alaikum dear students. Welcome to physics class. As you all know that today we will discuss about the physical quantities. Now before we starting the physical quantities, first we discuss its different terms which are used for physical quantities, in which three terms are used which are called the measurements, unit and magnitude. Now first we'll discuss the measurement. What is measurement? Measurement is a comparison between an unknown quantity and the standard to see how many times as big it is. Now, what is unknown quantity? These are the measurable quantities like mass and length. So, for example, if you want to find the length of the wire, which can be measured with the help of meter rod. Similarly, if you want to measure the time, it is measured by clock or wristwatch. If we want to find the temperature of a body, so we have a device called thermometer by which we can easily find the temperature. Next term which is used, it is the magnitude. To measure anything, a number and unit is required. This number and unit collectively called magnitude of physical quantity. Suppose we have 10 kg of sugar. So 10 is the number and kilogram is the unit. So 10 kilogram is the magnitude of physical quantity. Similarly, we have different magnitudes used in our daily life. For example, 10 meter. 10 is the number and meter is the unit. So 10 meter is the magnitude for the length. For example, 20 Kelvin. 20 is the number, Kelvin is the unit, so it is also the example of magnitude. 50 km per hour, 50 is the number, kilometer per hour is the unit, so it is also the example of magnitude. So we have different magnitudes for different physical quantities. Next is the unit. So unit is the standard with which the things are compared. Before measurement can be made, a unit or standard must be chosen. For example, the unit of time is second, the unit of mass is kilogram, the unit for thermodynamic temperature is Kelvin, the unit for volume is cubic meter, and the unit for area is square meter. So, their different units are used in daily life. Now we discuss the quantities. Now there are different types of quantities. First, which are categorized in two types. First is the physical quantities and then the non-physical quantities. Now what are physical quantities? All the quantities that can be measured are called the physical quantities. For example, the length of the book can be measured. The mass of the box can be measured. So length is the example of physical quantity. Mass is the physical quantity. Similarly, the duration of stay at school can be measured. So duration or time, it is also the example of physical quantity. Similarly, we have non-physical quantity. Those quantities which can't be measured are called non-physical quantities. For example, our dreaming can't be measured, so it is the non-physical quantity. Our emotions, our pain can't be measured, so it is the example of non-physical quantity. And our feelings is also can't be measured, so it is also the examples of the non-physical quantity. The next topic is about international system of units. Now, what is the requirement of units? As we have already studied that two main things required to express a physical quantity, which are the magnitude and unit. So measuring is not simply counting. For example, 5 liter milk, it expresses a complete and meaningful physical quantity. Here 5 is the magnitude and liter is the unit of volume. So, unit is very important to express any physical quantity. Now we study the requirement of SI. With the development in the field of science and technology, the need for a commonly acceptable system of units was seriously felt all over the world. particularly to exchange the scientific and technical information. So, in the 11th Journal Conference of Weights and Measures held in Paris in 1960 were adopted a worldwide system of measurement called International System of Units. So there are two major types of SI units, base units and derived units. Now we discuss one by one the base physical quantities and the derived physical quantities. Now, before starting this discussion, we define the international system of units that it is a complete set of units for all the physical quantities. The international system of units is abbreviated as SI units, and SI is a short form of French name System International. The international system of units is based on 7 base quantities and 7 base units, which are defined as the minimum number of physical quantities selected, and the units are defined and standardized such that in terms of these all other physical quantities can be expressed. So the 7 base physical quantities and their SI base units and symbols are given in the following table. Now on the slide you can easily see the table. It has the base quantity and SI base units. First is length. Length is symbolized as small l, small x, small r, and its unit is meter, small m. Second is mass. Mass is represented by small m, its unit is kilogram, represented by kg. Third is time duration, represented by small t, unit is second, and symbolized as small s. Fourth is electric current, represented by I or small I, unit is ampere, represented by capital A. Fifth is thermodynamic temperature, represented by capital T, unit is Kelvin, represented by capital K. Amount of substance, represented by small n, unit is mole, symbolized as mol. Last is luminous intensity, represented by capital I, unit is candela, represented by small cd. Now here you can see that small t for time and capital T for temperature. So there is a big difference between small t and capital T. Where we write small t, it means time, and where we write capital T, so it means temperature. If you write instead of small t, capital T and small t, so it will be wrong. Now we come to the derived physical quantities. So physical quantities defined in terms of base quantities are called the derived quantities. And some derived quantities with derived units are given in the table. Now the units derived from multiplying and dividing the base units are termed as derived units. In the table, you will see different derived quantity with their derived units. First is area, symbolized as capital A, and unit is square meter, m square. Second is volume, represented by capital V. Unit is cubic meter, m3, m power 3. Or we can easily read it as m cube. Third is speed or velocity, represented by small v. Unit is meter per second. Fourth is acceleration, represented by small a. Unit is meter per second square. Next is density, represented by rho. Unit is kilogram per cubic meter. Next is force, represented by capital F. Unit is Newton. Again represented by capital N, and value is kilogram meter per second square. Next is pressure, represented by capital P. Unit is Pascal. Next is energy, represented by capital E, capital U. Unit is joule, represented by capital J, and it has its own value. Next is capacitance, represented by capital C. Unit is farad, represented by capital F, and has its own value. Last is resistance, represented by capital R. Unit is ohm and has its own value. So these last two, capacitance and resistance, these you will study in class 10 book. And the Newton, Pascal, Joule you will study in different chapters step by step. So how we can obtain this m square, this m cube and meter per second? So here on the slide you can easily see that area has the formula length into width. So width is also the length. So length, the unit for length is meter and the unit for width is meter. So m into m, it becomes m square. So area equals to m square. Here the unit for area is meter square. Now how will I obtain this meter cube? Volume has the formula product of three length into width into height. So these are also the length. So the unit for length is meter, the unit for width is meter, the unit for height is meter. So m into m into m, it will be m cube. So the unit for volume is meter cube. In this table you can easily see meter cube or cubic meter. Next is speed. How we can obtain speed? Speed is defined as the distance per unit time. So distance and time both are the base quantities. So the unit for distance is meter and the unit for time is second. So meter per second is the unit for speed. Here s has the exponent plus 1. When it will become the numerator, it will be minus 1. So ms minus 1, or it can also be read as meter per second. Now here you can easily see speed or velocity, it is meter per second. Next is acceleration. Acceleration is represented by small e. It is defined as the time rate of change of velocity, delta v divided by t. So the unit for velocity is m by s, meter per second, divided by time is second. Now meter per second divided by second. Now according to the mass rule, divide will convert into multiply and the right hand side value, it will be inverse. So m into 1 equals to m and s into s equals to s square. When this square will comes to the numerator, we will get ms minus 2 or meter per second square. So the unit for acceleration is meter per second square. Now next is the density. Density is defined as the mass per unit volume. The unit for mass is kilogram and the unit for volume is cubic meter. So we have kilogram per cubic meter. Next is force. Force is the product of mass and acceleration. Mass is the base quantity, acceleration is the derived quantity. So the unit for mass is kilogram, the unit for acceleration is meter per second square. So we get kilogram meter per second square and it is equals to Newton. So the unit for force is Newton. Now in this table you can easily see all the units except the force, pressure, energy, capacitance and resistance. We have write the units in small letters, but Newton, Pascal, Joule, Farad and Ohm, these are represented by capital letters. Newton for capital N, Pascal is for capital P, Joule is with capital J, Farad is with capital F and Ohm. So these have written in capital letter because these are the name of the scientists. So all the units which are in the name of the scientist, so it will be written always in capital letters. Clear? So Newton with capital N, Pascal with capital P, Joule with capital J, Farad with capital F, because these are the name of the scientists. Now I hope that these all units and system of units are clear to you. So till the next class, Allah Hafiz.